Today we are going to discuss introduction to quadrant. So first of all, introduce quadrant. So uh, we know that quadrant divide into four part. Okay. Here written 0. Here written pi by 2, pi, 3 pi by 2 and 2 pi. So here circle starting from 0 and moving in anti-clockwise and complete one revolution, say 360 degree, that means 2 pi. Okay, here pi, that means present in degree form, and we know that the value of pi is equal to 180 degree. Now in case of here in 0 to pi by 2, we can say that first quadrant, pi by 2 to pi, so here say that second quadrant. Now pi to 3 pi by 2, so here we can written third quadrant, and 3 pi by 2 to 2 pi, so written here fourth quadrant. Now in case of first quadrant, all these trigonometric functions are positive in first quadrant. All these trigonometric functions, that means sine function, cos function, tan, cot, sec and cosec. So all these six trigonometric functions are positive in first quadrant. In case of second quadrant, only sine and cosec function positive, remaining four function negative in second quadrant. In case of third quadrant, so in third quadrant, tan and cot function present in positive form and remaining four function in negative in third quadrant, and in case of fourth quadrant. So in fourth quadrant, cos and sec, only two function positive in fourth quadrant and remaining four function negative in fourth quadrant. Okay. So in first quadrant all these function positive. In second quadrant only sine and cosec function is positive form. In third quadrant tan and cot function positive, and in fourth quadrant cos and sec function positive form. Okay, now after discuss some identity. Now after discuss some identity. So first of all we know that tan theta is equal to sin theta upon cos theta. Now after cot theta is equal to cos theta upon sin theta. Now after we know that sin theta, so sin theta is equal to 1 upon cosec theta. After cos theta is equal to 1 upon sec theta. So here we can also written cosec theta is equal to 1 upon sin theta. Here also written sec theta is equal to 1 upon cos theta. Now after we know that sin square theta plus cos square theta is equal to 1. So this identity written in another two way. We can also written sin square theta is equal to 1 minus cos square theta, and cos square theta is equal to 1 minus sin square theta. Now also written sec square theta is equal to 1 plus tan square theta. Tan square theta also written this side, so sec square theta minus tan square theta is equal to also written here 1, and cosec square theta is equal to 1 plus cot square theta. So again cot square theta written in this side. So cosec square theta minus cot square theta is equal to 1. Okay, now related all these identity and quadrant using by quadrant discuss some example. So our first question find the value of other trigonometric function. Find the value of other five trigonometric function. Okay, so our question is find out the value of other five trigonometric function. Now in our first question, here the value is given cos x is equal to 1 upon 2 and condition is given x lies in third quadrant. So our question is cos x, total 6 trigonometric function is present. So here cos x is equal to 1 by 2. That means one trigonometric function is present. And here condition is present, x lies in third quadrant. So first of all, here draw quadrant, and in third quadrant, we know that only tan and cot positive in third quadrant, right? So now here cos x is equal to 1 by 2, and we know that sec x is equal to 1 upon cos x. So first of all, using by this result, first find out the value of sec x is equal to 1 upon cos x is equal to 1 upon 1 by 2. Now 2 written in numerator. So here we get first value sec x is equal to 2. Now in our question cos x is equal to minus 1 by 2, not 1 by 2. So here we can written minus sign, here written also minus sign. Cos x is equal to minus 1 by 2, x lie in third quadrant, so we get the value of sec x is equal to minus 2. Now after find out, we know that sin square x is equal to 1 minus cos square x is equal to 1 minus cos x in place of written here minus 1 by 2. So written here minus 1 by 2 whole square. Now simplify this term. So 1 minus 1 upon 4. Take LCM. 4 we can take LCM here, and 4 multiply with 1. So 4 minus 1, that means 3 upon 4. Now here square form is present, so remove this square. So here we get two value, one is positive and another one is negative. So therefore sin x is equal to plus minus under root 3 by 2. Because square root of 3 not possible, so we can written here under root 3, but square root of 4 is possible, so here written square root of 4 is 2. But here one condition is present. Third quadrant is present, and third quadrant only two value is positive. Now sign is negative in third quadrant, so here written sin x is equal to only consider negative value, because here third quadrant is present. Now using by sin x, after find out the value of cosec. So cosec x is equal to 1 upon sin x. Now again substitute the value of here. So is equal to 1 upon minus under root 3 by 2. Now this data written in reverse order. So here written minus 2 upon under root 3. So cos x is equal to, we get the value of minus 2 upon under root 3. Now after find out the value of tan x and cot x. So we know that tan x is equal to sin x upon cos x is equal to sin x. In place of substitute this value, that means minus under root 3 by 2 upon cos x. In place of written minus 1 by 2, so here written minus 1 by 2. Now 2 cancel out here, minus sign also cancel out here, right? So remaining term under root 3. So here we get the value of tan x is equal to under root 3. Now using by tan x, find out the value of cot x. So we know that cot x is equal to 1 upon tan x. So this term written in reverse order, so we get the value of cot x is equal to 1 upon under root 3. Okay. So here in our question only one value is given, cos x is equal to minus 1 by 2, and condition is present x lie in third quadrant. So using by this condition, find out remaining 5 trigonometric value. Okay. Now discuss next question. Question number 2. Condition same. Second question. Sin x is equal to 3 upon 5. Value is present and condition is present x lies in second quadrant. So sin x is equal to 3 by 5 is present, x lies in second quadrant. So again we know that in second quadrant only two value is positive, sin and cosec, right? So first of all sin x is equal to given here, so using by this result find out the value of cosec. The cosec x is equal to 1 upon sin x. Now the value of sin x is equal to 3 by 5. So here written 1 upon 3 by 5. So now interchange the position of this value. So cosec x is equal to, here we get 5 by 3. So our first value cosec x is equal to written here 5 upon 3. Now second value sin x is equal to, here 3 by 5 is given. So we know that cos square x is equal to 1 minus sin square x. Now here substitute the value of sin. So the value of sin is 3 by 5 whole square. Now simplify this term and take LCM. So is equal to, here written 1 minus 9 upon 25. Now take LCM. So 25 minus 9, that means 16 by 25. Now after check out, here condition is present, cos square x form is present and second quadrant is present. So in second quadrant the value of cos is negative. So remove for the square root and here return only negative value, that means minus 4 by 5. Now after using by same value find out the value of sec x. So sec x is equal to minus 5 by 4. Right? Because we know that sec x is equal to 1 by cos x and this value written in reverse order. So we get the value of sec x. Now after find out the value of tan and cot. So again we know that tan x is equal to sin x upon cos x. So is equal to sin x in place of written 3 by 5 upon cos x in place of written minus 4 by 5. So here 5 cancel out. So remaining term tan x is equal to minus 3 by 4. Now this value written in reverse order. So therefore cot x is equal to minus 4 by 3, because tan cot x is equal to 1 upon tan x, and the value of tan x is equal to minus 3 by 4. So written in reverse order, so we get the value of cot x is equal to minus 4 by 3. Now next question. Question number 3. Cot x is equal to 3 by 4 is present and x lies in third quadrant. So here cot x is equal to 3 by 4 is present, and our question is x lies in third quadrant. So first again we know that in third quadrant only tan and cot function positive in third quadrant, remaining 4 function negative in third quadrant. So here using by cot x, first find out the value of tan x. So tan x is equal to, here written tan x is equal to 1 upon cot x is equal to 1 upon 3 by 4. So here written 4 by 3. So therefore here we get the value of tan x is equal to 4 by 3. Now after, how can we find out the value of sine, cos, sec, cosec? So here tan x form is present, and we know that one relation sec square x is equal to 1 plus tan square x. So here using by this result, sec square x is equal to 1 plus tan square x. Now tan x in place of written 4 by 3. So 1 plus 4 upon 3 whole square. So is equal to 1 plus 16 by 3 square, that means 9. Now take LCM. So 9 plus 16, that means 25 upon 9. So here we get sec square x is equal to 25 upon 9. Now remove all the squares, so we get two value positive and negative, but in third quadrant sec is in negative form. That's why here we can written sec x is equal to minus 5 upon 3. Now find out the value of cos x. So we know that cos x is equal to 1 upon sec x. So here written cos x is equal to 1 upon sec x is equal to minus 3 upon 5. So cos x is equal to, written here, minus 3 by 5. Now after find out remaining 2, means 2 value is remaining. So here find out sin x. So again we know that sin square x is equal to 1 minus cos square x. So is equal to 1 minus cos x in place of written minus 3 by 5. So here written minus 3 by 5 whole square. So is equal to 1 minus 9 by 25. Now take LCM, simplify this term. So 25 minus 9, that means 16. So 16 by 25. So remove the square root. So sin x is equal to, now third quadrant is present, and in third quadrant value of sine is negative. That's why here written minus 4 upon pi. Now after find out cosec x, so cosec x written in reverse order, so we get answer. So cosec x is equal to minus 5 by 4. Clear? Okay. Now take one more example. Sec x is equal to 13 upon 5. X lies in 4 quadrant. So here again 4 quadrant is present, and we know that in 4 quadrant only cos and sec positive in 4 quadrant, right? So here sec x already given in positive form. Now using by sec x, find out the value of cos x. So cos x is equal to, direct written here 5 by 13. Cos x is equal to 1 upon sec x, and 1 upon sec x in place of 13 by 5. This term written in reverse order. So we get the value of cos x is equal to 5 by 30. Now after using by cos x, we can find out the value of sin x. So sin square x is equal to 1 minus cos square x is equal to 1 minus 5 by 13 whole square is equal to 1 minus 25 upon 169. Now take LCM, simplify this term. So 169 minus 25, that means 144 upon 169. Remove for the square root. So sin x is equal to, we get two value, positive and negative form. So here we can written here plus minus 12 by 13. But here 4 quadrant is present, and in 4 quadrant the value of sine is negative. So that's why here written sin x is equal to minus 12 by 30. Now after using by sin x, find out the value of cosec x. So cosec x is equal to minus 13 by 12. Written in reverse order, so we get the value of cosec x. Now sec x, cos x find out here, sin x also find out here, cosec x also find out. Now remaining two function, so find out the value of tan x. Tan x is equal to sin x upon cos x. Sin x in place of written minus 12 upon 13 upon cos x, in place of written 5 by 13. 13 cancel out. So the value of tan x is equal to minus 12 upon 5. Now after using by tan x, find out the value of cot x. So cot x is equal to 1 upon tan x. So 1 upon minus 12 by 5. Now written in reverse order, so we get answer. So cot x is equal to minus 5 upon 12. Okay. So in our question, sec x is equal to 13 by 5 is present. X lie in 4 quadrant, so in 4 quadrant cos and sec is positive. So using by this relation we can find out remaining 5 trigonometric function.